Okay, can we do a definite integral with integration by parts? Oh, probably. If we're setting this up, let's get the formula up here just to remind us what we're doing. The integral of u dv is the same as uv minus the integral of v du. So we've seen before, we want to pick a u that gets easier when it's differentiated, and we want to pick a v that doesn't get too much worse when it's integrated. So in this case, we've got sine 2x, x, and the obligatory dx, and we're going to be finding values for u, for du, for v, and for dv. So my pick here, because we want a u that gets simpler when it's differentiated, I like this x for my u, because when you differentiate it, it pretty much vanishes, leaving nothing except a dx. That's what you want to happen when you're doing an integration by parts. Now, if u is our x, so I've taken care of that piece there, all the rest of this has to be our dv. So sine 2x dx, sine 2x dx, all that has to be my dv. That's not great. That's a little more complex than I'd like to see, but we can probably handle it. The antiderivative of sine is, well, derivative of cosine is negative sine, so this must be a negative cosine 2x. And when we do the chain rule derivative on this, a 2 is going to pop out, so to make up for that, I'm going to need a 1/2 out here. I did that a little fast, but feel free to check it and integrate this if you want, just to make sure that I'm right. This should be the antiderivative of sine 2x dx. So now that we have all those pieces, let's see what our new integral looks like. So we're saying instead of doing this, we can do uv, which would be, there's u, and v is minus 1/2 cosine 2x minus integral v, which is minus 1/2 cosine 2x. I'm going to put the minus and the 1/2 out front. Two negatives cancel out. So this is minus integral v and then du. Okay. U, v, minus, the negative canceled out, v du. So can we do this now? This definitely helped, because before we had an integral with x times a trig function, and now we have an integral with just a trig function. So this is an improvement. This is an integral we should be able to handle. Here we get, I'm just going to clean this up, minus 1/2 x cosine 2x. All I really did was change the order. And then we get plus 1/2 times, now the antiderivative of cosine 2x is going to be sine 2x, but because a 2 is going to pop out of here, we get a 1/2 again. That happened twice. We're going to have to multiply those halves together. And I'm not going to say plus c because this is a definite integral. So we get minus 1/2 x cosine 2x plus half times a half. There's our antiderivative. You can actually differentiate this if you want to check it. And after some cleanup and collecting terms, you should find that you get back to x sine 2x. If this is a definite integral, then we have to evaluate it by plugging 0 and pi into it. So let's try that and see what happens. When we put pi into this, we get minus 1/2 pi. Cosine 2 pi is just 1. Minus, oh, sorry, that's just the first term. Okay, so I put pi into this. I get minus 1/2 pi times cosine 2 pi plus 1/4 of the sine of 2 pi is 0. So actually I could have gotten away with forgetting that term, but it's better to not do that. Now if we put 0 in here, we get minus 1/2 of 0 times, well, cosine 0, but that doesn't really matter, plus, because there's a 0 in this term already, we know the whole term's going to vanish. And then we get 1/4 of the sine of 2 times 0, which is the sine of 0, which is 0 again. So when we finish cleaning this up, we get minus 1/2 pi plus 0, so that just vanishes. And then this whole thing vanishes, so minus 1/2 pi is actually the whole story. That's the complete value of the antiderivative. Or rather, sorry, not the value of the antiderivative, it's the value of the definite integral.